last class, we talked about creating a confidence interval for beta, or how close we thought our estimate from our sample was to the true regression line. So what we're going to do today is significance testing on that. And we need to think about what regression is and what the slope represents in order to understand what we're trying to prove. So, as always, our test statistic is going to be statistic minus parameter divided by the standard deviation of the stat, or in this case, t equals our calculated slope minus our hypothesized slope, b naught, divided by the standard error of b. So let's think about what we're actually trying to say here, which is that in general a null hypothesis is that beta equals 0, and that there is no relationship between the two variables. I don't know what that is, that's extraneous. Is that there is no relationship between the two variables. So what is our alternative hypothesis going to be? Well, our alternative hypothesis is going to be that either there is a positive slope, there is a negative slope, or that the slope is is not 0. Either way, then if we prove our alternative hypothesis, what we're really proving is that there is some kind of relationship between those two variables. There is some kind of relationship between those two variables. Not establishing causality, but we are establishing a link. And we're saying that statistically, it's highly improbable that this happened by random chance. The key, once again, it'll be a t-statistic with n minus 2 degrees of freedom. So here's an example. Infants who cry easily may be more easily stimulated than others. This may be a sign of high IQ. Child development researchers explore the relationship between crying infants 4 to 10 days old and their later IQ test scores. And they snap the kids on foot with a rubber band to cause them to cry. And then researchers recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. So, and they counted those number of peaks for the 20 seconds. And so they said then, at age 3, they gave them an IQ test, the Stanford Binet IQ test. And then they created a scatter plot, and the Minitab data is here. So what they did is, here is your crying, and here is the IQ. And so what they asked is there a relationship between the crying and the IQ? Do we have convincing evidence of that?
Agent Salamino, please report to the main office. Agent Salamino, please report to the main office.
And so does this data provide convincing evidence? So we're going to perform a test. And once again, our null hypothesis is that there is no slope. But remember, a line with no slope means that there is no relationship. No significance level was given, so we'll use alpha of 0.05. So this is always our first step. So we state our null hypothesis and state what we're trying to do. So then we'd have to check our conditions. Remember, the conditions are linear. Is the data linear? Well, here is the residual plot. Does not appear to be a pattern in the residual plot. So we would appear to have linear data. Independent. We had 38 infants, so as long as there's more than 380 infants in the population, then we're fine to sample without replacement. Right? Normal, so we look at the residual and we'd say, are the residuals approximately normal? And if we look at this, this is the normal probability plot right here, and that looks pretty linear, so I'm confident to say, now it says that there's a slight curvature, and actually if you look at it, You can see it, it's like this. There's a slight curvature, so the responses may not be normal. However, because our sample size is so high, the T procedure will overcome that. And it's not central limit theorem, but it's the same idea of a high sample size. The T procedure will shrug off the departure from normality. Equal variance. Once again, we're looking, is there a cone pattern in the variance, or is there some kind of thing in it? No. I mean, we have the 1 point up here, but overall, variance looks about the same regardless of the x value. And then random, we told that the 38 infants were randomly selected. So we've now checked all 5 conditions. So now we're going to perform our test. And what we'll see here is, here is the slope of the sample regression line. So we do that minus the null hypothesis divided by the standard error. And we get a t-value of 3.07. Now what's useful is, if you'll notice, that t-value was also given in the output, as was the p-value. And in this case, its degrees of freedom is 36, because there were 38 infants. And here's a picture of what that looks like. And so we get a p-value of 0.002. So this p-value here is assuming a two-sided test. Because we're one-sided, we divide it in half. Be careful about that. We'll learn how to do some of this in the calculator in a second. So we conclude the 0.02 value is less than the stated alpha, and that there is a positive linear relationship between the intensity of crying and the IQ score between the population of infants. It's important to remember, though, that showing correlation does not show causality. And these are the kind of tests you hear about all the time on the news, with showing a linkage between blank and blank. Scientists have shown there's a linkage between eating more asparagus and, not developing Alzheimer's. Or, I don't know. You hear that all the time on the news, and that's what they're doing. Is they haven't done an experiment. They've just done something that shows linkage. We'll be doing many more of these in class tomorrow, and really getting the handle on doing the significance testing on beta.